Hello, my name is Frederick Jacob. Today I will present my FIP title Removal of Simulated Dye using Terminalia Cattapa leaf as adsorbent. My supervisor is Dr. Nur Fatiha Wayuni binti Cik Juso. Without further ado, let us begin. Dye are organic pollutants that are widely used in industry and usually release straight to the environment. Dye are important material that give color to other substances and also the major contributor to water pollution. Do you know there are many types of dye? For example, there is anionic dye and cationic dye. Anionic dye is negatively charged, while cationic dye or basic dye is positively charged. Example of anionic dye such as methyl red and methyl orange, while example for basic dye are methylene blue and rhodamine B. The adsorption method proven as highly efficient in removing hazardous pollutant and effluent. Adsorption is method transfer process similar to absorption. In absorption, the atom enter into the bulk phase of a liquid or solid, whereas adsorption, substance adhere to the surface of the molecule. For this research, simulated dye were prepared to imitate real dye condition. Terminalia Cattapa leaf or TCL can be found easily anywhere in Malaysia. It is low cost, easily obtained, and has high adsorption ability. Let us proceed with the problem statement. Effluent from industry which contain dye is released to the open landscape and water bodies. Due to its good solubility, some dye is resistant to be removed and pose a serious risk to the environment and health. The conventional adsorbent such as commercial activated carbon is not preferred as it is considered costly. Move on to the first objective, which is to evaluate the potential of TCL adsorbent for the removal of simulated dye. Next objective is to analyze the adsorption kinetic of simulated dye over TCL adsorbent. Adsorption kinetic for an adsorption process is the rate of uptake of the simulated dye on the adsorbent by the rate controlling step. The third objective is to propose a mechanism for adsorption of simulated dye using TCL adsorbent. For the first scope, will carry out by using batch adsorption with different type of adsorbent treatment such as nitric acid, HNO3, sodium hydroxide, NaOH, and non-treated. Initial concentration of simulated dye of 50 mg per liter, contact time of 60 minutes, room temperature, and adsorbent dose of 0.2 to 1 gram per liter. The second scope is to evaluate adsorption kinetic using pseudo first order and pseudo second order. The third scope is to have better understanding on how the proposed mechanism for the adsorption of simulated dye over TCL adsorbent work. This is the procedure for preparation of simulated dye. In this case, the adsorbent, the solution that will be adsorbed. Firstly, to prepare 50 mg per liter of concentration for methylene blue, the mass of methylene blue required were calculated using the equation provided. In this case, 12.5 mg. 12.5 mg of methylene blue were taken and weighed and put inside a beaker to be dissolved with 150 ml volume of distilled water. Then the same step were repeated for methyl red, methyl orange, and rhodamine B. Lastly, 250 ml, 50 mg per liter each of methylene blue, methyl red, methyl orange, and rhodamine B were mixed together in 1 liter of beaker to prepare simulated dye stock solution of 50 mg per liter. This is the preparation of TCL adsorbent. Adsorbent is a substance that absorbs the simulated dye. The TCL adsorbent were firstly treated with nitric acid, the TCL HNO3 by washing with distilled water several times. Next, dry at 45 degrees overnight and blend using dry blender to powder form. Powder was sieved to size of 50 to 100 micrometer. Next, 6.3 ml of nitric acid was dissolved with distilled water up to 500 ml. Mixture was filtered and powder residue washed with distilled water. The filtered biomass dried at room temperature and in an oven at 60 degrees Celsius for 2 days. Lastly, dry biomass was stored in airtight plastic bottle to protect from moisture. For result and discussion part, we discuss on the effect of treatment. Terminalia Cattapa leaf adsorbent were treated with different kind of chemical treatment such as nitric acid, sodium hydroxide, and non-treated adsorbent. The non-treated adsorbent TCL9 showed the highest percentage of MB with 83.39% compared to two other adsorbent. For other dye, the non-treated show moderate removal. The acid-treated adsorbent TCL HNO3 prefer to adsorb anionic dye or negatively charged dye. which are Mr and Mo, due to simulated dye pH is lower than the point of zero charge. Since the surface is positively charged, it will prefer the adsorption of anionic species. The concept is like how magnets work. Different charge will attract each other. Point of zero charge described as the pH at which the net charge of adsorbent surface is equal to zero. Meanwhile, basic treated adsorbent TCl-NaOH favor to remove basic dye or positively charged dye, which are MB and RB, due to the solution pH is higher than the point of zero charge. Since the surface of the adsorbent is negatively charged, it favors the adsorption of cationic species. As we are looking for the adsorbent which can remove both acidic and basic dye, TCl non can be a great adsorbent as it shows moderate removal for all type of dye. Cell surface of TCl are anionic due to the presence of ionized groups such as carboxylate, hydroxyl, and phosphate, therefore attract basic dye, while the presence of polar functional group of lignin in TCl such as alcohol, aldehyde, ketone, acid, hydroxide, and ether as chemical bonding agent help in chemical and/or hydrophobic sorption. To summarize, the graph on the right shows effect of adsorbent dosage against time. For the effect of adsorbent dosage from figure 2, we can observe that there is an increasing trend from adsorbent dosage 0.2 until 0.8 gram per liter for removable percentage of all dye. However, after further addition of adsorbent dosage to 1 gram per liter, there is a decreased trend for removal of dye. According to Verma and Mishra 2008, state that the increased adsorbent dosage resulted in more binding site on the surface of the biomass for adsorption, which resulted in increase in dye removal. The explanation for the reduced of removal rate after 0.8 gram per liter is due to agglomeration of the adsorbent when the dosage is raised. This shows that the adsorbent already reached equilibrium, and further addition of adsorbent dosage lead to a decrease in removal percentage. Therefore, 0.8 gram per liter was taken to be the optimal dosage for this condition. Adsorption kinetics were conducted to understand and study the kinetic for an adsorption process to explain the rate of uptake of the adsorbent on the adsorbent and support to anticipate the mechanism of sorption and the rate controlling step. Table 3 shows the pseudo first order and pseudo second order for adsorbent treated with acid, base, and untreated adsorbent. Parameters for all types of treatment were also included based on data obtained. R2 for second order show higher value than R2 for first order, hence pseudo second order were chosen for modeling. All the graphs also shown better fit for pseudo second order than pseudo first order when plotted. Moving on, figure shown the proposed mechanism for dye adsorption. Components that make up plants such as lignin and cellulose consist of variety of polar functional group. Cell surface is mostly anionic, negatively charged, and attract basic dye due to the presence of ionized groups such as carboxylate, hydroxyl, and phosphate in different cell wall polymer, while presence of polar functional group of lignin in TCl such as alcohol, aldehyde, ketone, acid, hydroxide, and ether as chemical bonding agent help in chemical and/or hydrophobic sorption which attract anionic dye. As a conclusion, the TCl non-adsorbent is selected as it can remove both acid and basic dye at the current adsorption condition. The optimal condition for adsorbent dosage is 0.8 gram per liter. The adsorption kinetic revealed that adsorption kinetic follow the pseudo-second order for all type of treatment. Study on proposed mechanism is important to have better understanding on how adsorption of simulated dyes on TCl adsorbent work. That's all from me. Thank you.